Hello everyone. Today we want to discuss about how we can graph sine and cosine using the unit circle. First of all, I want to discuss about why we are actually eager to draw and visualize these functions. First of all, if you actually want to model a periodic motion in a real life, mostly you should use sine or cosine functions. Sine and cosine functions are the fundamental in modeling any periodic motion, such as waves, oscillations, and vibrations. So for this purpose, we are interested in how we can visualize these functions. In order to visualize these functions, we use a simple method, so you guys don't have to actually memorize their graphs. Use a unit circle, which you guys are mostly familiar with. You can also see the previous videos. We're gonna go from the degree of 0 radians to the degree of 2 pi radians in increments of pi over 2. So we're gonna discuss how these functions, such as sine and cosine, are gonna look like in each of these variables and values. So starting from the 0, I'm gonna name this graph sine. I'm gonna name it sine of theta, and the x-axis would be theta. I'm gonna name the graph below it cosine theta, and the x-axis would be theta. So starting from the 0 point, what is the sine value and cosine value at this point? As you guys can see in here, the cosine has a value of 1 and the sine has a value of 0, because this point is already on the x-axis, which is the cosine axis, so it doesn't have any value for y. So the y value would be 0. So we're gonna put this point in here. When theta is equal to 0, sine is equal to 0. When theta is equal to 0, cosine is equal to 1, as you guys can see on the unit circle. If we move one step ahead, as we mentioned, we are going to move in increments of pi over 2. So, by the way, we are also moving in this direction, which is anti-clockwise. If we move by pi over 2, we get to this point. At this point, which is theta equal to pi over 2, we get the sine equals to 1. So I'm gonna name this pi over 2, and the value of y would be 1. Also, for the other one on the below axis, which is for cosine, what is the value of cosine at this point? As you guys can see here, this point is already on the sine axis, which is on the y-axis, and has no value on the x-axis, because it is already located only on the y-axis. So the cosine for this point would be equal to 0. So far we have gotten 2 points. Now we're gonna move further down. As you guys can see here, if we move to this point has a theta of equal to pi here, and when theta is equal to pi, sine of theta is equal to 0 and cosine of theta is equal to -1. I'm gonna name this -1. We're gonna move to pi. When theta is equal to pi, we're gonna have -1 in here. And for the same, when theta is equal to pi, we have a sine equal to 0, as you see in here. Now we're gonna move by increments of pi over 2. We get to the position of 3 pi over 2. So when theta is equal to 3 pi over 2, the sine value would be equal to -1. I'm gonna name this 3 pi over 2, and this one would be -1. So we have this point in here, and for this one, we actually name this one as well 3 pi over 2, and for this one 3 pi over 2, as you see here, is on the y-axis, so the x value would be equal to 0. And so we get to the last one, which is 2 over pi. Sorry, it is 2 times pi. And as you can guys see here, actually we've completed the whole revolution when we get actually to 2 pi. So when theta is equal to 2 pi, we have the cosine equals to 1. Yeah, and for this one, the sine would be equal to 0. So as you guys can see here, we've got the main points in here, the sine axis and the cosine graph. We've got the main points in here. So what I want to do now is connect these points to see how the graph will look like. If you connect it like this, we got the sine of theta has a curve shape like this, and starting from here, we have the cosine of theta has a shape like this. Now, what happens if you actually want to move forward and continue getting the values for sine and cosine for thetas more than 2 pi? So, as we mentioned before, we're gonna actually proceed with increments of pi over 2. So if we actually want to continue more, we would get, after 2 pi plus pi 2 would get us to 5 pi over 2. And for 5 pi over 2, which is this point in here on the graph, we would get the value of 1 again. So I'm gonna draw it with green. It would be like this again. And if we actually continue doing this way, we are gonna get the same shape in here as well. You can actually imagine it. And also for the cosine as well, if we actually continue giving theta different values, this shape that you are already seeing in here is going to be repeated. That's why these functions, sine and cosine, are also called periodic functions, because the shape is actually going to be repeated. And as you guys can see here, the periodic value for sine is equal to 2 pi. It means that after 2 pi, which we have completed the whole revolution, the function is going to repeat itself. And for cosine, it is the same as well. After we have completed the whole circle, the cosine graph is going to repeat itself again. So, now, if you guys want to see the whole complete cycle of sine and cosine, you can see it in here. As you guys can see in here, the blue graph is representing the sine of theta, and the red graph is representing cosine theta. And in other words, if you guys actually look more deep into this problem, you can understand that if you actually shift sine of theta backwards by pi over 2, you get the cosine of theta. As an example, if you move this point backward by pi over 2, we get to this point. It means that if we actually shift this graph by pi over 2 to the left, we get the cosine of theta.